Worst case, I will be a bit slow, but that should be within our reach. Worst case, I will be a bit slow, but that should be within our reach. So we are live on YouTube. Worst case, I will be a bit slow.
Say something. I think I can hear myself a little bit. Yeah, I can hear myself.
Yeah, I just now mute YouTube. So I have YouTube open but muted.
Okay.
So that should now work, I think. So I will have to be careful not to watch myself there, because that's going to be disturbing. I now fear that we have a lag.
Yeah, but not on Zoom, right? We have a discrepancy on YouTube.
On YouTube there's a lag, but that's normal. But I was just fearing if between us there's a lag. But apparently no. You hear me live. You see my lips moving.
No, everything is live. I don't have any delay.
Okay. So I will have to do my best not to be distracted by myself there, because I will see myself with, myself and yourself with this. I think it's almost 20 seconds difference. It's interesting.
Oh,
but that way I can
is it that long?
Yeah, that means people that we pick up there will be a bit after us.
Okay.
But yeah, they will also raise the questions whenever they see it, so we have to answer it whenever we see it. So that's going to be a little lag, but I guess it's nothing really dramatic. So that was stage 2 of the rocket, and now stage 3 of the rocket is to find out how you start a room in Clubhouse. Oh, so apparently 15 minutes before you can start the room. Because before I was opening the screen and it wasn't giving me the opportunity to start the room, but now I can. Let's not start it straight away, because if I start it straight away, whatever we say here is going to be live.
Just do it. I think it's not the issue, right? I don't see any issues doing this right now.
Just a couple of things. Yeah, you'll see my arguments. You shouldn't have too much difficulty to win today, I think.
I never thought about that there is any issue. Oh, what is this? There's something on the screen in French, and now we have a colored picture. All right.
Okay, if that happens, I have to press the button, because usually, I'm using a driver which connects via USB with my camera, and that works smoothly. And for what reason today, that driver doesn't want to work. So I had to go through HDMI. So I took HDMI out of my reflex to go into the computer, but apparently that thing will sometimes just pause the camera. So I would have to press a button. Perfect. But it's okay.
All right. We have Alex on board.
Hello, everybody.
Hi.
Can you hear me?
Hello, Alex. Yeah, perfectly.
Yeah. Okay, good. Nice, very nice.
How are you?
I'm doing fine. It looks like I speak with the same headphones like you do, Björn.
No, I'm using this micro because this gentleman to the left said to me that using the AirPods for speaking are not as good as if I would use a mic. And that's why I invested $70 into this mic, because we had a podcast together, and in the end it turned out that my voice was not so good.
Okay,
and that's why I changed
I have these earbuds. I hope the batteries last, so they're fully charged. Typically it does. So yeah, it will.
Normally an hour they should last.
Yeah.
An hour they should last. All right, just Antoine, just to 1, 2, 3 words about today. You will do the intro.
Yep.
Okay, and then I will introduce Alex in a later stage if it comes to the point. So in the intro, we will say, hey, we have a guest today, which is Alex, and I will introduce Alex if we are ready with our clash somehow.
I think we don't to spend too long.
Will I be visible during your clash, or do you upload me with the mic, with the video in the second part only?
It's up to you.
Well, you're on stage. So basically, you're sitting next to us.
Okay.
So if you want to shut down your micro and your camera, you can. But I think it's part of the really interesting part of today is that we have you as a guest. So
okay, good. The documentation that I sent over to you prior to this for your preparation. Any questions you run over me in the second half? Okay, up to you. Or should we clarify anything beforehand?
I think a little bit it will be like this. We will have the clash, then I will introduce you, right? And then you have your 5 minutes somehow. After the 5 minutes, I will ask you a couple of questions based on the information you gave and what I could found and what I have in my head. And during this time, Antoine will check the chat, whether there are some questions from the people out there. And then I will give the word to Antoine and he will read the questions and or let's say he will give the questions from the audience to you.
All right.
I think that is somehow the way, right? We wanted to go.
And if we see, I mean, last time we had lots of questions. If we see there's less questions for whatever reason, then
I have good ones. I have really good ones.
But I would be the candid. So, you know, like, I don't know anything. And I might ask stupid questions. Of course, because I'm French and stupid, but also because that's my role. So, two reasons
your
to
role,
that.
right?
The stupid questions are the most difficult ones.
I can, let's say the idea of the questions, Alex, is a little bit CapEx, OpEx, something like this. I mean, the membranes are driven by this. What else do I have here? Yeah, I mean, where's your target audience, right? Do you go to the suppliers or end users, something like this? Yeah, testimonials, whether you have any references where you really, let's say, before and after. Is there anything you have so far? I mean, we all know, even this I will say during my introduction, that you are established since 2019. So, and then the pandemic came and now we are in the beginning of 2021. So I think you are more or less 1.5 years old with your company. Yeah. I can't hear you anymore.
I think you muted yourself.
No, we can't hear you. And that's.
So
yeah,
audio's on. I think the space bar can toggle between audio on and audio off. Is that correct?
Yeah, on Zoom, the space bar is the magical tool.
The space bar. So you can hear me now?
Yeah.
Okay. Yeah. 2019 was the year of establishment of the company. That's correct. But we are a week away from our first financing round. So basically, the operational activities of the company have not really started yet. So we are a spin-out of the research institute. I will explain a little bit about that. So that's the situation we are in right now.
Okay, very good, very good. Yeah, these are these kind of questions I have a little bit. But look, anything else? Yeah, limiting factors. What kind of material? Or I think all polymer membranes, right?
All the porous membrane materials for the reverse osmosis membranes, we almost can't do anything. We do not concentrate on them, but we can touch that later.
Yeah. Yeah, that's something like this, right?
All right, cool.
Very good. Okay. All right. And after that, as I said, then we will have the questions from the audience. And after the questions from the audience, then we go into the closing. I have some trends here for the membrane industry, and then we will close the session. Today, we, just for your information, Alex, we are multi-streaming. So we are live on Zoom, we are live on YouTube as well. We are live on Clubhouse. So
okay, yes, thank you. If I need some experts on that when I want to do the same, I know who I can turn to.
Yeah, the French guy, the French stupid guy.
The French guy sits over there from my view. So
no.
Okay.
Perfect. All right. Anything else, Antoine? How are we at the moment?
I mean, so far we're still between us. Whenever I push the button, we will be.
Do you see how many are in the green room right now? Can you see that?
No, as long as I don't start the webinar, I don't see them. But if I start the webinar, they will start popping up.
Okay.
So what I propose you is that we will switch to live, if it's good for you.
I'm fine.
Let's go. Let's go.
Just housekeeping before we start. Björn referred to you as Alex. Shall I refer to you as Alex or Alexander Braun, as you wish?
Alex, it's international. That's the perfect. That's the good thing about a name. So whatever you like, Alex is cool.
Okay, good. Then let's hit the various buttons. Good. So if there's anyone joining us now, we are live on Clubhouse. We're already live on YouTube and from now on, we are as well live on Zoom. So no worries, no worries. Don't press yourself. It's not 5. We don't start before 5, and still, whenever it's 5, we still have a couple of minutes, for the one that might be joining a bit late. But welcome everybody. Welcome to this session.
Even from my end, welcome everybody. Welcome Antoine. Welcome Alex.
Hello everybody.
Very multinational today, right? 2 against 1. How does it feel, Antoine?
Yeah, to be honest, I'm not expecting to win today. I'm going to give my best.
As always, you're sandbagging a little bit, right?
Yeah, it's known that the French are the one that surrender, right? So, but I'm not going to surrender. So I'm going to do my best to win this debate. So I'm just for the one that don't have us with the video on, because we also are live on Clubhouse right now. To explain you a bit, on stage we are right now we have 3. So you might see only my profile picture on Clubhouse, but don't worry, you will hear all of us 3. So there's Björn Otto, my counterpart. So Björn, if you want to make them hear your voice, that's the moment.
Hey, good afternoon, everybody. We are really happy to have you here to the second session. And what I can tell you is that we are very, very excited because we are multi-streaming today on 3 channels, and we have so many people who said, hey, they want to join. So it's really fun and really exciting to see you all here. And yeah, as I said, welcome again. And I'm really excited to have the show and to have the clash today with you, Antoine.
And it's not yet 5, so I will present our guest when it's actually really 5. And for now, you're still our mystery guest. So we have a mystery guest, don't worry. But we'll tell you about it in a minute.
In a minute.
If you were not with us last time, the purpose of today is to have a discussion with contradictory arguments between Björn and myself. And we might not agree on everything. We might even disagree on everything. But hopefully at the end, the topic is going to be the winner. And that's everything we hope for all of us today. So not that I would like to spoil the conclusion or to jump to conclusions. Good. Let me do the official introduction. At my clock, it's 5. So with my rambling, it's going to be 5 and 2 + 5, so we are going to be all good. So welcome everyone, and welcome to the second session of the Time for Wastewater. So time for water, waste, between brackets. The purpose of those discussions is to have two different views on the same topic. And today our topic is going to be membranes in wastewater. So membranes in wastewater is something which is not around for such a long time that there would be an absolute consensus on is it cool or not. Is it the best way? Is it the worst way? Does the silver bullet anyways exist in water treatment? So you'll see that we might have some debate with Björn, and I think that's the right time for the one that just joined us to introduce you, Björn. So, hi Björn, welcome to your own show.
Yeah, welcome Antoine to my show. And yeah, as you said, right, today we have chosen the topic membranes and wastewater. Is it really a serious alternative? From my perspective, is a no-brainer. I'm pretty in some pretty simple words. I mean, we can close the session because everybody would agree. Yes, it is definitely a serious alternative. But unfortunately, I have to fight against you and I have to convince you a little bit about this. But anyway, will be a short session, I think, right?
Okay, so you're really starting with that. Before we enter into the debate, let me just mention that we have a special guest today with Alexander Braun, which we agreed to call Alex. So Alex, welcome as well to the session. Alex will have a difficult role today because for the first half of our discussion, you don't have the right to talk. So it's really going to be Björn and me telling things which you might fully disagree and don't like. And then it's up to you and it's your stage, and you will have 5 minutes to tell us why you're here. And I think there's very interesting stuff to uncover in the reason why you're on stage with us today. And then we will have some debate between the three of us, or mostly the two of you, and I will be the voice of all of you in the room. So if you have any kind of questions, use the Q&A, use the chat. If you're on YouTube, use the chat. If you're on Clubhouse, you can raise your hand, and we might bring you on stage for the last part of the discussion, where you might have the chance to ask some questions to Alex, or to vividly tell us that you disagree with everything we say. So to conclude this introduction, you will quickly notice that Björn thinks membranes is the best thing there was, there is, and there will ever be in wastewater. And to me, it's a nonsense. So those are the starting positions. And I think with that said, Björn, can you maybe shortly introduce us to the topic? So what are we discussing today?
Yeah, well, thanks a lot, Antoine. One more point, please use the chat function if you have anything to say, and we will collect all the questions and we'll bring them on stage at the right point. Yeah, we will take care about all the questions. Yeah, today, as I said, membranes in wastewater. I mean, just to come with a number, what I have recently read is that the market for membranes and water is around 3 billion. So 3 billion is the market for all kind of membranes, which is incredible for our industry. But I think we have to a little bit to distinguish. We said, okay, we want to talk about membranes and wastewater. And the reason why this came up was a little bit that we talked about micropollutants last time, which is the logical step afterwards that you can use, or that you have to use a kind of separation where you can use a membrane. So we came to this conclusion. And to distinguish a little bit, we have to know a little bit, if we talk about wastewater, then we have to know that we have the primary, we have the secondary, and we have the tertiary process. And we have to distinguish the membranes we use in the secondary treatment process, which is mostly something which is integrated into the biological step, mostly an Mbbr or even an Mbbr, something like this. Maybe you know this Mbbr a little bit, Antoine, because you had a very nice guest last time. And we should think about the membranes we want to use, or we have to use, as a kind of polisher, which are coming in the tertiary step, as kind of to separate the solids. And even there, we have our field is so huge. We can talk about microfiltration. We can talk about UF. We can talk about ultrafiltration, nanofiltration. We can talk about RO. We can talk about something which is pretty cool, which is a forward osmosis, right? Even this is pretty cool. Very hard to explain, but it's a very cool technology. We should talk about ceramic membranes, which is coming, from the back and a little bit, to push this market, to push the polymers. This you can see as well. So there's so much to talk about. There's a huge market. And one more thing, if we are talking about distinguish, what we want to talk about is we have to distinguish also the municipality application compared to the industrial application. I think the municipality is a little bit different, maybe a little bit easier to explain. The industrial, there's no one-fits-all solution. I think that's clear, right? Because the industrial, what they do with their wastewater afterwards for reuse, for discharge to the river, they go directly to municipality to, they have a side stream separation, whatever. There's so many options that you can't really put them all together, right? It's not like for the municipality where you have the primary, secondary, and tertiary treatment, and then you say, hey, you have an Mbbr, or maybe you have an RO. It is a little bit different. So we have to distinguish that, and I think that should be enough. I think it is very clear that we want to use all the membrane in wastewater for the wastewater, just for one reason. I mean, do we really want to stay with a technology which was developed in the 18th century, right? We are meanwhile in the very modern world, right? We have developed so many cool technologies. We put our brain on the table and said, hey, let's do something. And we still, we are very, very conservative, right? Very, very conservative industry. But does it mean that we still have to stick to a technology, that we can't develop the technology further? We have developed 200, 300 years ago, Antoine? Is that really, do you really make that serious?
What you're saying here is that because we can use membranes, we should use membranes. That sounds.
No, we know what the outcome will be, right, from the membranes, but we still are so conservative that we are a little bit scared to use that for a couple of reasons, that we stick to a technology where we know also the outcome, and we say, hey, we could do it better, but nobody is really taking the risk on their own. That's my feeling a little bit. But I will give you the stage for the moment.
Let me just deconstruct that for a second. That means that what you're saying is that we have this good old thing which is called nature, which is cleaning water for some millennia and more, some 100 millennia. And you're saying now that we are an arrogant species called humans. We can build membranes. So if we can build membranes, let's put them in the water and let's treat with membranes. And tomorrow, if there's a new technology, you're going to replace membrane for the same reason. So I'm not going to make this one-to-one comparison. I think let's move the debate forward. What I'm raising is why do you think we need membranes? Because basically what you're saying is that because we had activated sludge, because we had the way we were treating wastewater since the beginning of the 20th century, there must be something which you don't like in what we were doing traditionally if you want to replace it with membranes. So what is it? What is that problem that membranes solve that I cannot solve with anything else than membranes?
Well, I'm not saying that you can use it as solve it with anything else than membranes, but let's say I would take one argument you throw to my head last time, which was I want to bath next to the municipality, right? So I want to bath there. So that means if I want to bath in the river where the municipality is next to, I want to make sure that the quality of the water is as good that I can jump into the river without any harm. So that would be, we know this, that we know something better and something more from the technology point of view, instead of just having the activated flood process and the separation. And to do this, we need something, right? So if, we are smarter meanwhile, not only to develop, we are also smarter to have a look into the analytics to see what is really in the water we bring to the river, we discharge to the river. So the analytics, meanwhile, is so good that we know exactly what do we treat and what do we not treat. So, and we have discovered there are a lot of stuff which the municipality with their 300 years old technology is not able to process. So, and we know this, and due to the conservative factor we could solve that, but nobody is willing really to invest into that. To give you another buzzword, maybe you want to take.
Yeah, you've mentioned investing. That's a good point. Actually, you know that markets, Björn. I'm not teaching you the water sector. There are basically two drivers. The first is you're forced by regulation to do something. The second is you have sufficient money to do something. And hopefully both of them work together. Mm-hmm. Tell me which regulation shall force me to put all my wastewater through ultrafiltration, or you even mentioned forward osmosis. I hope you were joking, because that would be really a waste of energy and a waste of time and a waste of money. So if there's not a regulation and a regulatory driver, why would I do that? Because at the end of the day, what you're saying is that we should wash whiter than white. But if we could start by putting our money at the right place so that we just wash white everywhere, including in the 80% of the world where today we are not treating anything, then probably we can then retake that discussion and say, how, now that we've treated everything to a basis level, why not go the extra mile? But for now on, it sounds to me like, first world problem. Let's put membrane in wastewater and it's going to be so clean.
Why did we talk last time about micropollutants? There's another word I can bring to the topic. You're waiting for the regulation. If we always would wait for the regulation, I think even Switzerland wouldn't have done anything, because they realized they have to do something with the micropollutants. There's another topic, which are the microplastics, right? We discharge so much microplastics, so much micropollutant to the river. We all know that, but we, except southern Germany and Switzerland, we don't do anything against this. So that's why we need a technology who can solve that. And membrane is one of the technologies who could solve that, because we got a quality out of the membranes, which is definitely better for the river where we want to discharge.
Okay, so that's a point. I'm not debating. It's true. You take your wastewater through a membrane, it's going to be much cleaner. But is membrane the only way to do that? I mean, instead of putting a membrane, what are we talking here about? We're talking mostly about membrane bioreactors, right?
Right. So
instead of having our membrane bioreactor, we could be having, I don't know, a moving bed biofilm reactor, or we could be having an SBR or a BFFR. I mean, so many different technologies. And I can list you many advantages of those technologies over membranes, like less fouling, less scoring of the membrane. I mean, and the list goes on. So why membranes?
Well, we say, yeah, you're right. There are other technologies as well, but do you reach with all the technology? You mentioned SBR. I think SBR is not a membrane technology, right? So we have to make sure that we compare apple with apples. So we need a kind of membrane technology to reach the quality in water, which we cannot achieve with anything else. The other point is, we talked about quality. Okay, I think we agree on that. But the other point is, think about space, especially today. Space. For an Mbbr plant, you need around 1/3, 1/4 of a plant of a conventional system, so which is a big driver. I mean, yeah, you in France, maybe you have very much landscape and you don't care if you want to build a new one or if you want to extend the wastewater treatment plant. But think about cities like Dubai, or where you have Singapore, where you have a population really, where you don't have any space any more further to extend your plant or to build something new. That will be a little bit also the driver. And if you think about other technologies, you have to put this also in the basket. Not only the quality, you can also think about what is really the space you need, right? And there also a membrane technologies nails it really down, that you need very, very, less space compared to conventional system. So
Basically,
yeah, that's why membrane.
you used your two arguments, and now it's going to be difficult for you because basically those are the two arguments in favor of membranes. They take less space, of course, because you have a higher concentration in mixed liquor, suspended solids, and they give you a good output. Yeah, of course, there must be some arguments because if there was no argument in favor of membranes, nobody would be using membranes. But now let's get serious on the alternative. What is really treating this wastewater inside the Mbbr? It's this biofilm that you're building on the membrane, and that biofilm could be built on anything else. Think of activated sludge, of course, the grandfather of all these technologies. But I'm coming back to my comparison to Mbbr. If I was operating an Mbbr, I would have all the advantages of that. But I don't have any kind of fouling. I don't have to look at my silicate. I don't have to look at all my salts. I don't have to look at my at high aeration costs and backwashing of my membrane and chemical washing of my membrane, and the list goes on and on and on. And if I want to bring that list at the very bottom of it, what are we talking about? We are talking about OPEX, high energy costs to run my membrane bioreactor or any kind of membranes. We are talking of OPEX again because if you have a lot of chemicals, those don't come for free. And we are looking at CapEx on the midterm, because if you regularly backwash, regularly bring some chemicals on your membranes, well, you have to replace your membrane at some point because it's not magic. At some point, they age and they get destructed by the process. So on the short run, and if you're really looking at a place where space is an issue above anything else, so let's say Hong Kong, Singapore, you mentioned Dubai, but not even Dubai, because there's the desert behind Dubai. You have plenty of space. So outside of Hong Kong and Singapore, your argument to me falls a bit short. How can you balance this economic aspect of the Mbbr?
No, I don't let you go away with that. You said only in Hong Kong and Singapore. Have you ever been to India? Have you ever been to India? So I've been many times, and there is one thing, what you do not have there is space. If you want to extend your plant, if you want to extend your municipality, if you want to build up something new, you always nailed to where you are. It's not that we have to say about Hong Kong or Singapore or even Dubai. Even Dubai is very nailed because you can't put somewhere in the desert a municipality, or even in Oman, right, where you have all the rocks. On Dubai is limited to the sea from one side. Doesn't matter. Space is definitely one point, right? You should not forget. So, and you mentioned Mbbr, so which is very interesting because I thought we wanted to talk about microplastics. So, and my question is, Mbbr, that means we have these small carriers which are somehow made from plastic, and we put them in wastewater. But we want to avoid to put the microplastic into the rivers. On the same time, we are putting some kind of plastic into the municipality, and on the same way, we are discharging plastic, microplastic to the river. So even there, we have not the same quality with an Mbbr, and you need more space with an Mbbr. Yeah. Not so far as a conventional system. You're right. You did your homework, but definitely you will not reach the quality of an Mbbr.
I have the feeling, Björn, here that we are comparing apples with potatoes, because you are raising me the quality output of an Mbbr, and I'm raising you all the other aspects of the Mbbr. But if you compare Mbbr to Mbbr, you have to take in account that probably if you really need to reach that same level of quality that you are alluding to, which is nowhere in the regulation and nowhere in the word a must, but if you need to reach that, then why not put something behind your Mbbr? Talk about a sand filter, that's not an issue. It still doesn't solve, to me, the problem and the difficulty to operate a membrane bioreactor. Because a membrane bioreactor is a more clever and more complex way to do activated sludge. But you still have the activated sludge there. So all the the questions of sludge recirculation, of sludge age, of managing the biology inside your plants, all of these, they are still there. So that means that your operator needs to be highly qualified. For him, it's difficult. Whereas on the other end, if you're operating, and I'm taking Mbbr, but any kind of fixed film carrier. I mean, it could be a carrier, it could be a fixed film in a reactor at itself. It's much easier. You just put it on and off, and that works.
Yeah, so, but is that? Go ahead. I don't want to interrupt you.
In terms of operations, there's a big difference between membrane treatments, which are much more of an engineer's dream, and other kind of technologies which can be much more sturdy and maybe not give you the same output, but an output which is sufficiently good to meet regulation thresholds, to meet the treatment objectives, which is to keep the environment clean and in a good state. So that's a bit what I'm missing here in your argumentation.
But is really your argument that you are saying, hey, we don't want to train the operator to a level where he can operate a membrane. So we are saying, hey, we are not able to do this. So we keep him on a lower level that he can operate something different. One thing. The second thing is
it's not a lower level.
Yeah, you are saying that, but it's so complicated to run an Mbbr. I mean, to run an Mbbr plant compared to conventional system, all studies have shown that you need less manpower. So why? I mean, your argument doesn't count really, right? So, and I think we have so much good technologies on the market. We should bring the people to the point that they are able to use that. Same as we are able to use all the technologies we are using at the moment, right? With YouTube, with Zoom, and so on. So even the operator should be able to use the technology which is given in the market, right? Because otherwise it doesn't make any sense from my perspective. If you say, hey, it is too complicated. I invited something totally cool. We can clean the complete wastewater to zero, but it is too complicated. We don't give it to you. We want to stay on a different level to make sure nothing goes wrong. Is that really the argument?
I mean, Björn, you've been involved in tenders, you've been involved in the municipal world and in the industrial world. In the municipal world, it's about our money as a society. How much are we ready to pay for that? In the industrial world, it's even worse. It's water is just a cost to you if you're an industrial player. Water is a mean to achieve something and to produce a good which you're going to sell. But if that mean becomes really too expensive, well, you relocate somewhere else where water is cheaper. And it's not because you're a bad guy, it's just because everyone has to make his profit and his margin at the end of the day. What I'm saying here is I'm not trying to be the devil's advocate. I'm just trying to say you have to put the benefits and the cost in a balance. And to me, the benefits and the costs are not so well balanced with membranes. But maybe we can keep that debate for later, because I have the feeling that we won't agree on that one. So let's see later in the last part if the panel.
Give me one sentence to that, because the tertiary treatment which is ongoing for the micropollutants in Switzerland have definitely shown that there is an acceptance even by the people who are using the wastewater or producing in this case to pay something more to save and protect the environment.
You mean in Switzerland?
Yeah, even in southern Germany, where you have all the plants upgraded,
and
right?
So
they have to pay a little bit more. And it is accepted by the people, right? So, and I think one thing we should also do not underestimate is what we can do with the water. What comes next? What comes after the membrane, right? I mean, I'm thinking about.
I get you, because that's the part where you're at home with your membrane. Let me come back to the problems. You said it, like the pink glasses. So let's take the pink glasses off and let's have a look at that. You're running an Mbbr, right?
Yeah.
And then suddenly there's a change in the water quality, and you get some grease or some really high fluctuations, and your membranes get fully clogged. And what can you do? You just all your arguments about water quality, you're just not treating anymore because your membranes are out of order. They cannot do anything.
Well, it is, even if they are clogged, it's not that they don't process anything anymore. They are processing less. definitely. If
You double or you triple your energy costs. Come on.
Yeah. I'm agree with. If something goes wrong, something goes wrong. I mean, this is definitely the case. I mean, you don't want to have. So that's why all the big municipalities have multiple stages, right? If something goes wrong in one tank, they can even process an N-1 process to take all the wastewater to something else. So you increase the flux, right, for the membranes, and then you can take care about the module or the membrane which clogged, which is fouled, whatever you have to do with that. I mean, yeah, then you need some manpower, then you need chemicals, then you need whatever, right, to bring this in life. But I think that something can go wrong. I mean, can happen. Even if you go on the motorway, your car can broke, right? Even this can happen. But is that the case? I really calculate with that something goes wrong and my membranes maybe I go fouled.
Yeah, but that's something which goes regularly wrong. Because come on, a membrane doesn't like clay, sand, microalgae, grease, hydrocarbons, metal sulfide, and on top of that, you have the biofouling. And if there's some salts within your water, then you get crystallization within the membrane. And salts is any kind of anion cation which go into a pair. You could have metals. You mentioned the microplastics, for sure, that's a problem, but there's also the heavy metals, and the heavy metals, they clog the membrane. So, and if there's any kind of polymer which for whatever reason goes out from your primary treatment, and then you have your membrane which is fully clogged. So, I mean, don't tell me that happens as rarely than your crash on the motorway. Come on, that happens every day. Björn, you've been on planes like me. You know that happens every day. There was even this study, from using artificial intelligence in the UK, where they were able to show that two planes were just discharging water above the limit, and they just had no clue, because if you're a human, your brain cannot process so much information. So what I'm saying is that even when you're on the plant, so much is happening all the time. And on top of that, there's so much you don't even see. And you're saying, hey, come on, I put a membrane, it's going to be clogged, but who cares? Come on, Björn, be serious.
I'm not saying who cares. I mean, you have to care. But I think what I'm saying is, I mean, especially we talked about municipalities. All the things you mentioned which come in are not the regular stuff which come into the municipality. And if you know that comes in, then you have to protect your membranes. That's for sure. That's the biggest issue you can have with your membranes, is that your pre-treatment is not working, and then you will find the issues always on the membranes. Yeah, I mean,
expensive.
You're
right?
What?
Your pre-treatment has a problem, and now you have an expensive problem because you need to replace your full system, which was you had forced to have an amortization over 15 years, and now it's 5 years, and it's expensive. I'm exaggerating because that's. But
Antoine, I mean, you have to replace the membranes. Yeah, I mean, you have to take care about the pre-treatment. If that isn't working, if that failed, then you have to do something with that. But it's not that you have to replace the entire plant. I have seen membrane plants who failed. Yes, you're right. I have seen many plants who work smoothly without issue. So there are always plants who are going well, and some who are not going well. And it is not always the case because of the membrane. It is sometimes because of, I mean, we have so many sources where the issue can come from, that you can't say, hey, it is because of this, right?
So, okay. What I propose you, Björn, is that we're not going to agree here. So let's put the dispute on ice, because I'm having a close watch to the watch, actually. And let's bring a new argument into that field, and I'll let you introduce our special guest, and that way we will elevate a bit the debate, because for now your arguments don't click with me.
Okay, maybe he can help me out, but definitely after that you are gone. All right. All right. Yeah, today in our show, the first time that we have a guest. So let me introduce him first of all. Today we introduce Alex Brown, which is the CEO of the company Q Code from Leipzig, Germany. and which is a startup who was established in our industry in 2019. So it is almost 1.5 years old, so very young for this company. And they provide, and I have to read this now because this is a very long sentence. They provide smart performance functionalities to polymer membranes or water purification and the entire fluid separation industry. In short, they just boost the membrane functionality by coating your membrane to the next level. And what they are saying is, we have, after the coating, we have 100% a longer membrane lifetime. We have 40% higher throughput through the membrane, and we have 68% less fouling. And how does this really work? Alex will now tell us. So welcome, Alex, and good to have you here on our show.
Hello, everybody. Björn, Antoine. Nice to be with you. Thanks for having me. It's a real pleasure. It's a pleasure.
Perfect.
It was interesting to listen to you, Antoine. I can't imagine that you're really so strong against membranes. Maybe Björn and myself, we can convince you otherwise. Let's see what we can do over the next 30 minutes. I think we have heard over the first 30 minutes that membranes really came a long way, and I'm inclined to say, and in many cases, they did a great job. But we at Q-Code, we are convinced that membranes can do more, can do better, can be more robust. Maybe they can even be more intelligent and can provide their basic purpose, separation, in a more efficient way. Björn already introduced what Q-Code is all about: efficiency. And efficiency of the membrane, that means to the membrane operator, in many, many cases, a lower total cost of ownership. And while the lower investment costs have been the driver over the past, under the new paradigm shift that we see today, that means sustainability, the attention, I believe, has moved more to the membrane capabilities as such and operating costs over the membrane full lifetime. And here we see membrane fouling as the biggest contributor, and we all know that includes several types of running costs: membrane cleaning, membrane maintenance, energy costs, and not to forget the skilled labor costs. And for this needed boost in membrane operational efficiency, Q-Code has a solution. As we already heard, thank you for that. It operates, or the solution is applicable to all across the drinking and wastewater purification, the entire fluid separation industry in general, and in particular to membrane fouling. How do we do this? We coat regular membranes with smart molecules. And we were able to show with them the membranes achieve a higher level of throughput, up to 40%. The percentage of membrane fouling can be reduced in the high 60s. And a combination of many effects can increase the membrane lifetime itself up to 100%. That's true. When we speak about membrane coating, you need to understand that's a rather simplistic image for the general public or for the general operator. As a chemist, you would say it's called molecular functional crafting, and that's exactly what we do. We attach tiny functional molecules in a very dense pattern to the existing membrane. So afterwards, the membrane interacts differently with the water passing through or other aqueous solutions. You understand, with our treatment, the membrane receives new advanced functions on the external as well as on the internal surface, having contact to the water. And this polymer surface treatment technology is a result of more than 10 years of intensive R&D at our mother institute. It's the Leipzig-based research institute for surface engineering, and we have done a couple, close to 10 prototype field tests with different industrial partners from different fields of applications. And my company, Q-Code GmbH, basically is the most recent spin-off from that research institute. In contrast to competing anti-fouling technologies, our smart molecules on the membrane can ensure the performance level to stay the same over the entire membrane lifetime. And that means over the entire membrane lifetime, the operator can save energy up to 25 to 30%. And the good thing about it is that the membrane itself retains their original separation characteristics. So our intelligent, especially carefully adjusted molecules that we put on the membranes are so small that the pores in the membrane keep the original diameter. So a microfiltration membrane remains a microfiltration, a UF remains a UF, and a nano remains a nanofiltration membrane. And it also works for flat sheet as well as for hollow fibers. And more importantly, the membrane can be assembled the very same way as it was the untreated membrane into filter modules or into cassettes, and all the manufacturing technologies can remain the same. So there's no change for the downstream value-added chain after Q-Code. So coming back to the term of efficiency, you understand that a higher permeability can lead to smaller membrane components, especially also smaller overall system size, and a lower fouling tendency directly relates to a lower maintenance effort.
Alex, I have to cut you in half a minute.
Yeah, sure. Yeah. Okay, so maybe one more explanation on the microscopic membrane surface water interaction. Yeah? Depending on the application, all molecules on the membrane surface achieve an extreme hydrophilicity, and at the same time they reduce the chance of the permanent adhesion of suspended biomaterials to the membrane. You can imagine that the flow flushes away those loosely bound particles so that this permanent adhesion and the blocking of the membrane pores never happens. That's basically what we offer to membrane manufacturers as well as to module integrators.
One of the reasons, and thanks for that introduction. One of the reasons I had to interrupt you is that we have interesting questions in the chat and in the Q&A for you, and then I'll let Björn come with his own questions. But I'd like to bridge two of the questions received in the chat. So one question is from Egon Batik. He mentions that membranes are used just for solid separation on wastewater treatment plants. They must be properly selected not only as membranes, but as membrane technology separation. And the lifetime of a membrane shall be across 20 years. And I'll bridge that with another question from Ruby Dudley, who's saying that coated membranes, what is the additional membrane life? He says that Kubota guarantees 3 years, but many designs assume 10. So is the increase with your technology from 3 to 6 or from 3 to 20? So.
For a startup, it's a difficult question to speak about years into the future, but we have extensive experience. As I said, the technology dates back more than 10 years ago. So we have membranes operating over more than 5 years in the drinking water purification, but it's a good indication that the membrane surface improvement lasts over such a long time. When we speak about membrane lifetime extension of 100%, then it adds up from different areas how the membrane is attacked during a lifetime. You all know that a membrane needs to be cleaned with chemicals. Sometimes it needs to be backflushed with high pressure, and all that naps on the mechanical integrity of the membrane. When we operate through to the higher permeability, the membrane at the lower pressure, all that adds up to potentially 100% longer membrane lifetime. With our industrial partners, we break it down to say 30% membrane lifetime extension. That's enough. That's good for the commercial calculations. The 100% is achievable, can be shown in the lab, but I think in real life, in real applications, plus 30% is good enough.
So let me just recap that one for me to make sure that I understood it. It means that in the lab, you were able to reach 100% longer, so to double the lifetime of the membrane, but you're saying to cope with real life applications when you're partnering with industrial players to make it real in the field, you give a 30% estimate of the additional lifetime.
30% estimate, that's correct.
Okay. Thanks. Björn, do you want to take it, or do I take another question?
Just let me jump in, and maybe you can collect some more questions. My question a little bit, Alex, is what is your business model? Are you going to the, let's say, to the suppliers, which is in my case, for instance, an OEM, where they can coat the membrane and they pack it on their modules and ship it to the end clients? Or are you going more to the end users, let's mean to the municipalities or industrial facilities?
We are not a manufacturer of membranes. We are the holder of a technology how to improve an existing membrane. So that means we offer our membrane treatment solution basically to the membrane manufacturer itself, but we also can provide this technology to the module assemblers. In many cases, they have their preferred membrane. They've been working with the membrane for years. They know their customers, but they know it could be better in this or that respect. And we were able to, I keep the word coat, surface craft certain types of intelligent smart molecules on different types of onto membranes, so that we are not afraid of whether it's a PES or PVDF membrane, PN or different kind of membranes. We have a tool set, so even the membrane integrators, membrane assemblers can come to us and say, okay, this is my preferred membrane. Can you make it better for me?
You mentioned coating. So I just jumped on that one. We have a question in the chat from Norbert Seltzer, who is asking you to explain a little about the characteristic of the modified surfaces. Is it more hydrophobic or more hydrophilic or mixed domains?
It's a combination of extreme hydrophilicity and to lower the chance of adhesion of a suspended solid. So, and in order to achieve that, we select certain types of molecules. When you look at hydrophilicity, which have a hydrophilic binding site and also a hydrophobic binding site, and during our improvement step of the membrane, those small molecules turn in a way that the hydrophobic binding site turns to the membrane, and the hydrophilic side turns later on to the water side. So what the water sees when it passes through the membrane, interestingly, also the inner walls of the pore, so any surface portion of the membrane that the water passes by, that's improved by our technology. Not only the visible surface that you can see with your human eye, but also the internal surfaces that are hidden.
Björn, I'll let you take the next one, and then I have two cool ones in the chat.
Perfect. The reason why I was asking this, what is your business model, was for me, I mean, the market becomes more and more price sensitive, and we know it is always it's always about capex against opex. So opex comes later. So, but the person who has to decide and has to purchase the equipment, the material, is interested in capex. So that means if I assume I would be a membrane manufacturer or whatever, I would get my membrane coated with you, and I get maybe better benefits out of that, or definitely I will get better benefits of it, but definitely I will have to sell it for a higher price, which is a little bit against the market. what would you say about this? I mean, how much I would have to increase a little bit the price to compared without coating the membrane?
Mathematically, you're absolutely correct. The treated membrane is more expensive than a non-treated membrane. But we've been able to show through to the beneficial effects the treated membrane has, the payback time of those additional value addition. Those payback time is about 25% of the overall membrane lifetime. So the remaining 75% that goes into the operational pocket or into the pocket of the operator.
But the payback is interesting for the end user and not for the OEM. Am I right? So, but all I want to say is, you have to give this argument to the OEM, and he has to go to the end user to give this argument to the end user, to the municipality, for instance.
Municipality or different types of end customers? Yeah, sure.
All I want to say is, wouldn't it be an idea? Just let's take the word from Antoine. My stupid brain. If you would go to the municipality and say, "Hey, you have a membrane in here. Let's take a Kubota Mbbr. You have a Kubota membrane in, and you have to replace that. And the normal lifetime of this Kubota is, I don't know, 5 years. And with the coating of the Kubota membrane, you would last 10 years. Take just the numbers. So then the municipality would go to Kubota and say, "Hey, you have to replace this, but I want to have a coating." Wouldn't that the better way that you inform somehow the end user that he goes with the information to the supplier to squeeze them?
That's been the focus of our prototype project that we did so far in order to make the technology visible and also to show to the end user what is there and what he should or could expect from his suppliers. But again, we see ourselves as a technology provider. We cannot, as a young startup company, we cannot deal with every and any end user. So we have found our sweet spot within the value-added chain between the membrane manufacturer and the membrane assembler, filter module assembler, and that's what we understand. And of course, the value-added money needs to be distributed downstream to the end user, because he pays for the final product. And in our mathematical economic calculations, we have done this, of course.
Perfect. Antoine?
If I can interrupt you, I have many questions in the chat. So if you can make short and dense answers, that would be awesome. I'm sorry, I'm really putting a lot of pressure on you, but I'm excited because they're really cool. First question from Fajr Mushtaq. So what pollutants or matrix effects can negatively impact the molecular crafted coatings? Or in other words, is there any particular water composition that renders your coating ineffective?
Wow, I have no answer in many cases. So you need to understand. First of all, you speak with the membrane manufacturer or with the module assembler for what particular application he wants to have a smarter membrane. And then we select the type of molecule, and then we put it onto the membrane. So that's basically the question that you battled over in the beginning. So what's there if hell breaks loose? What happens to my membrane? Please understand that we have a tool set of smart molecules to put onto the membrane, but always we need to know in advance for what specific application. Municipal Mbbr, for instance, basically are all the same. And then we already heard it in the industrial wastewater treatment. They're all a little bit different, and so are our surface coatings on the membrane.
So that means you have like a bank of applications. If it's within your bank of application, then you have a direct answer, and if not, you would be running a test.
Yes.
Okay.
After 10 years, we have seen many, and we have good starting points for those tests. Yeah.
A question from Sebastian. How are these molecules affected by chemical cleaning?
None. Stays the same. They stay on it. Very stable, has been tested over and over again. So standard cleaning procedures, no topic.
We have a question from Pranav Sharma. He's asking, he wants to know how is the high 2F coatings used by Q-Coat different than polyelectrolyte coating layer by layer modification? Just mentioning while you are...
It's a different process how to apply it onto the membrane. And in our case, the chemist says we form a covalent bond with the membrane backbone, and therefore it cannot be washed away, it cannot be washed out. I don't know about, especially with those other technology, and as our molecules are so small, as I said, the membrane retains their separation characteristics. So we do not change the pore size of the membrane. When you do a real layered membrane coating, you definitely do something with the pores and their separation characteristics. We do not do that.
We have a question from Rabbit Dudley. Do membranes shed microplastics? Who of you want to take that one?
What is the question?
Do membranes, was his first question, then he iterated the question 20 minutes later, do coated membranes risk to shed more nanoparticles? So basically, would you be shedding more things because it's coated? My stupid brain would say no, but
yeah,
there's some risk.
We have this question a couple times, also some other cleaning procedures like with sponges in the Mbbr system. So do they do abrasion on the membrane, things like that, or if there's some other hard stuff particles still floating around? Yes, they can abrade the visible surface of the membrane, but as I said, we coat and graft all internal surfaces as well, where the water needs to travel by, stays the same. So the overall characteristic of the membrane after the treatment remains unchanged.
So Pranav, thanks you for your answer. So thanks for, in the name of Pranav, I'm thanking you. And we have another question from Soumya Chakrabarti. I hope I don't pronounce that too terrible. Can we use the coating in used membranes? Because he's having a tertiary treatment plant. So basically, can you use it to revamp existing plants, or is it only on new builds?
The treatment works in a roll-to-roll fashion on new membrane material, which is afterwards assembled into filter modules. So no, on existing filter modules, it cannot be applied.
So those were the specific questions addressed to you. I have one which could be for any of you. Bezad Sirkin is asking for a concrete example. Can you maybe tell us a story of a real life example of what you've done? A cool story.
A cool story is we've been with a pilot project partner who surprised us with features of the treated membrane we never thought about it. and this, I cannot tell the name, but this goes back to the mechanical integrity of the membrane and the components which were needed inside the membrane when you cast the membranes, pore formation and everything. And what we have not talked about today here on the show, that our technology consists of a dip coating. In the solution, there's the intelligent smart molecules, and then there's an irradiation by electron beams. And those electron beams, they have an additional positive effect on the membrane integrity itself. So it was a very interesting outcome of those with that pilot project partners who told us interesting things about our membranes, which we were kind of prepared for, but it was interesting to go into exchange with the guys who really applied the membrane to their product, to their solution.
We then have many, I would say, mix of question and testimony, which are linked to the beginning of this conversation today, which are really, they are pro membranes in the chat and they are against membranes in the chat. It's pretty interesting because sometimes the same argument fall on both sides. So I don't want to put a coin back because we're not going to agree. And I have to tell you and to crack a secret, I'm playing a role today. So I don't want to get too extreme here. But how can you explain that we have people saying like AR is saying membranes in wastewater need a lot more expertise and depends on the level of operation, automation, and which part of the world they are installed. And he's giving the example of Middle East, which has been a disaster for Mbbr plants, where many renowned operators successful outside the Middle East have struggled. And I'd oppose the testimony from, let me find that one back, which is about the lifetime of the membranes. But we had a second, because here, that message is really to tell us that people that were applying Mbbr in the Middle East failed, and apparently they were skilled, and still they failed. And on the other hand, we have Egon, and Egon Batik is mentioning that he has been operating in the wastewater treatment plant in Brescia, PVDF hollow fiber membranes installed in 2002, which are not changed yet. So how can you have on both ends like people who are terrible experiences and other who have incredibly good experiences?
Björn, you are serving longer in the membrane industry than myself, but maybe to give you a short introduction, I hope you understood that the operational side of an Mbbr, of a membrane itself, that's the point that we focus on. And when you can lower the operational efforts, you also lower the entry barrier into applying a membrane for wastewater treatment. And then you need less skilled people to operate such a membrane facility. And maybe it is the point who is working on what type of membranes for what purpose. And
well, yeah, maybe I can jump in to help you out a little bit here. I mean, it is what I have realized over the last 15 years. It is never the membrane. It is never the membrane, or let's say very seldom the membrane on its own. It is, you have always to have a look on the entire process, and the issue you will find is always on the membrane, but that doesn't mean that the membrane is the issue. That is a little bit the case. And if you take care about the entire process, especially about the pre-treatment, especially that you have stable conditions which will not change, your membranes should be very fine. And to the argument in the Middle East, well, yeah, I have seen some plants who are totally failed in the Middle East, but also one of the biggest Mbbr plants is in Muscat, Oman, right? So it's not a regional issue. It is always the issue of how you set up the entire wastewater treatment plant with membranes. So that's a little bit the case.
It's black and white, and there's a human factor involved, even if it's technology. I don't want to be too French and to be too long, but there's really a very good question, which I would like to take still. I have to apologize for all the other ones. We cannot take everyone, and really thanks so much for all the ones that have been here with us today. We will be taking the question from Nasrin, who's going to be the last one for today. If you appreciate the format, don't worry. There will be a follow-up. But let's take the question from Nasrin. Nasrin is asking, as a module builder buying membranes from a manufacturer, how does coating the membrane affect manufacturer's warranty if they don't endorse any kind of modification on their membranes? Has that even been a problem before?
Good question.
That's a question that we face every time with the membrane manufacturers, but we are able to solve that with a very tight quality check with protocols and everything that needs to be accepted from both sides, the membrane manufacturer, our side, and even the user of the membrane itself. So quality control, close checks, documentation, that's the answer for that.
All right. But do you give any guarantee? Is there any guarantee, or let's say more
For the
warranty in
process,
this case?
for the quality of the process that we put, or for the process, yes, we have to. Yeah, we have to.
What is this? What is that? What is this kind of?
For instance, there is constant checking of the hydrophilicity of the treated membrane, and that can be documented, and that goes into the documentation of the membrane leaving our pilot plant right now.
All right, good.
Okay, I would have a ton of question, but if I start having follow-up question, then we'll never end the webinar. And it was hard last time to keep it to 1 hour, so let's stick to that rule. Let's have a last round of housekeeping. If people want to follow up on the project, follow up with you, Alex, where can they find you?
They can find me on LinkedIn, Alexander Braun. Q-Code is the company, and if you do so, please look at the open position. We are hiring a sales agent, a key account manager. I'm happy for many applications to that open position.
Maybe something for Antoine, because he wants to learn something about membranes.
It's going to be a tough job interview for him.
All right, perfect closing words. Huh?
What's your closing? Where would you want to redirect people after that session?
I would like to invite the people to coming back in 4 weeks from now for the next session. And I would like to invite all the people who wants to be on stage as Alex, who has something to say, who wants to present, who wants to go on, who wants to get roasted from us as well, from the audience. Just drop either Antoine or myself a mail, and the topic for the next session is not finalized, but I'm pretty sure it will something with wastewater, with something, or what we have already talked about. So we will stay in the line. So if you think you have something to say, you want to be on stage, just drop us a mail. Hi, we would be happy to see you next time here, as well all others. Hey, in 4 weeks from now, we will have the next session, and you will see the next blue eye for Antoine.
And I will close with just I would send you, if you're interested in the membrane topic, I would send you to one episode of the Don't Wastewater podcast, so my podcast. I was interviewing Graham Pierce, and it's really, we made a full over 1 hour because I couldn't stop asking him. It was like a membrane Bible to me. It was so interesting, and you'll see that I was much less talking than today and much more listening, and what he was explaining was so incredible. I mean, I learned the full history of membrane. So if you want to have a listen to that one, I can just Graham Pierce made an awesome job on the podcast.
Oh yeah, he's a great guy. He's really an expert.
Yeah, for once it was not the stupid German, the stupid French, but the good guy from the UK, which was there from the beginning. So, and with those silly words, we had the perfect conclusion. But I had to talk because I'm French. I have to thank you, everyone, for all the ones that have been with us on YouTube. Thanks a lot. All the ones that were with us on Clubhouse. Thanks a lot as well. I'm sorry we couldn't take you on stage, but there were many questions left and right. So see you in 4 weeks. And thanks.
Same for me. Thanks all. Thanks, Antoine, and as well for sure, Alex, to be on stage. Hope to see you very soon. If you like, get connected with us, with Antoine, Alex, and me on LinkedIn to make sure that you don't miss any further episode, any further information we want to share. And we're really looking forward. See you next time. Take care. Have a nice evening, and goodbye.
Goodbye.